Hey everybody, Hake Hardware here, and in this video I'm going to test out my GMKtec EVO X2 with the Strix Halo, and it has the 128 gigabytes of memory. So if I just bring up the system here, I've got the Ryzen AI Max Plus 395 with the Radeon 8060S, 128 gigabytes of installed RAM, 64 of that is dedicated to the GPU. However, if we take a look, we can see we have up to 95.8 gigabytes of shared system memory. And I wrote this little Flask app that's basically going to help me test out some of my AMD mini PCs because I want to see how they do for the different models. And right now we're just going to focus on the DeepSeek and the GPT-OSS models. So these are already downloaded, and I'm running Ollama on the back end here. So we'll be using the API to basically run specific prompts. I'm actually just going to choose one because DeepSeek is really, really slow on the Strix Halo. So I'm just going to do one prompt. For the GPT-OSS, I might do different prompts. These should really equal the same token output. And this is maybe a little bit different type of benchmark for like people that are measuring like TG128 or PP512. Those are more standardized as far as like just ensuring that like your specific hardware matches, what is expected from your hardware. This I'm just testing out just to see what it does. And I kind of want to track this over time because I think things are improving with AMD integrated GPUs. And I also just want to see how much faster the Strix Halo is compared to my 890M, my 780M, and my 680M, just to see the differences. So I'm actually going to just kick that off. So there's going to be this one single prompt, just like a quick small prompt is going to be sent 3 times per model, and it's going to take the average basically of that. So we'll just go ahead and click Start Benchmark, and I'm going to leave the video up here, and you can see the GPU in the task manager here. We can see as these models load in, and we can see the first one is actually going already right now. And what it does, it'll load this model. It'll do the same prompt. The prompt is, what is recursion in programming? Give a brief explanation. It's going to do that 3 times per model. And then, so we'll see here as this model finishes up the third one, it's going to offload it, or not offload it, but it's going to eject it. And then we'll load the next one, which is going to be the 7 billion parameter. So you can see it uses just a little bit more memory here. So we're just going to let it continue through here, and then I'll come back at the end and we can look at the results. Let me bring myself back here. Okay, so we just finished up all the benchmarks, and I don't know why the system information is not updating correctly. It's just a manual input that I have in the setup.py file. But anyways, looking through this, we can see the different token speeds here, and GPT-OSS is just way better. I don't know like the specific details about why DeepSeek is so much slower, because we have like 70 bill here and 120, but this is 35 tokens and that's only 4 tokens. Like, I think 32 billion model is probably like the only or the most usable one as far as size. I don't think I could possibly use the 70 billion model. It just is too slow. But when you have like GPT-OSS doing 35 tokens and we have 48 for the 20 billion, granted like 20B it's not great. And you can see this fits in 64 gigabytes of memory. So if you do have 64 available, you can use the 120B. So even the Strix Halo that only has a 64 gigabytes, actually, I don't know if you have enough with that because you don't get the full amount. So like I have 128, but there's only 95 available here. But if you had dedicated, I guess, 64 gigs, you'd probably make it fit. But sorry, that gets a little bit close there. And then you can see all these, of course, fit in. The 1.5 billion was 1.8 gigs. 7 billion was 5.3 gigabytes. So these are in megabytes, of course. And yeah, so overall, like time to first token was, 10 seconds. Although it took as long as 30 seconds, it looks like here. Total seconds for the prompt, anywhere between 12 and 39 seconds. So pretty quick. This took a long time. This is why I don't think it was usable. Even this doesn't seem very usable. And again, this doesn't really measure how good the models are. This just measures how well it works with the hardware. And this is like a real life example. There's a lot of people, again, that show like more specific like metrics that are standardized and repeatable. But each time I run the prompt, you get a slightly different answer. So it's going to be slightly different, which is why you see, for token speed, it was anywhere from 35 to 36. But you can see most of them are pretty consistent. It's like for the 3 runs that happened, there's not much variation. There is some variation for time to first token, and there's definitely some variation for like the total seconds spent. But overall, just a good way of comparing. So what I'm going to do, I have this JSON here, and I have a compare results section, and this is really like dirty, but if we pull in the benchmark here, I actually don't have a second one to compare. So actually I have 2 of them here from earlier. And we can see basically like the 2, we can compare like the tokens per second for the Llama 3.2 1 billion model with the prompt for code generation. And we can see, these actually are the same computers that I'm comparing, so it really shouldn't be different, but we can see that you can compare them. So what I'm going to do is start it out with the Ryzen AI Max Plus 395 with the 8060, and I'm going to go through all my mini PCs. And I even have I've got a dual 5060 Ti system that I'm going to check out, and I also have a 9060 XT dedicated GPU with 16 gigabytes of memory that I'm going to check out. Granted, I won't be able to run like the 120 billion model. I'm just going to run only the models that fit on the available VRAM. So anyways, I figured I'd show this off just to kind of give you an idea of what's coming, but also this is just an open source public repo that I created. You're welcome to use it and give it a try. I don't know how great it is. I think there's probably like some really good official like LLM benchmarking software out there, but I just wanted to write my own, have a little bit of fun. And I'll probably keep improving it just because it's fun to have my own that I can do like specific things and post them like on my Substack and make YouTube videos for them. So anyways, still messing around with the Strix Halo. I have the GMKtec EVO X2 version of it. I wish I had the framework version. It'd be fun to mess around with that one as well. So far I haven't had any cooling issues, so I don't know if you saw, like, I sped up the video, of course, but I don't think we got much above like 80 degrees Celsius for the GPU. CPU, I don't know if we even have temperature here, but I haven't really seen any temperature issues. I think some people are maybe putting it on its side, which blocks like all of the air ports, and of course that's going to run really hot. You have to stand it up on its side so it's like vertical, and then it works pretty good. Anyways, that's it for this video. There's going to be a bunch more with all of the different GMKtec mini PCs with all the different internal GPUs, and then of course we have some external GPU stuff we're going to do as well. And mainly focusing on Windows initially, but eventually most of this stuff is going to end up living in Linux, just because that's usually a little bit easier if I'm going to be testing things and trying new things out. So anyways, hopefully it's helpful, and I'll see you in the next one.